Hi everyone, this is Dr. Chantel Marshall once again for Psychology 210. This lecture will be going over the two-factor ANOVA, which goes along with the second half of chapter 13 in your textbook. This lecture will not be covering repeated measures ANOVAs. Let's just go ahead and jump right in. This lecture will cover a few things. First, we'll start with an example, actually two examples of some studies that have more than one factor. So specifically, we'll be looking at two factors and how they might interact. From there, we'll move on to defining and understanding interactions and main effects within a two-factor ANOVA. And then moving on to hypothesis testing with two-factor ANOVAs. The really fun part about a two-factor ANOVA, I'm sure you all will agree, is that it has three hypotheses. So it actually has three sets of hypotheses, I should say. So a null and an alternative for three different types of effects. So that's a lot to be working with, but it's cool because we basically look to see if all three are significant at the same time. So we don't necessarily have to run three different tests. We can just run one test and figure out whether all three are significant or not. And then, really importantly, we'll be moving on to interpreting ANOVA graphs. So figuring out whether something is significant with a two-factor ANOVA could be as simple as looking at the graphs. And in fact, I'm not going to ask you to calculate the two-factor ANOVA in this lecture. I think it can be done, but I'm more interested in your ability to look at a graph and figure out if the effects look like they're significant. That's a very important skill to have when you're running these types of statistics. Okay, so let's move on to an example. As I've talked to many of the students here and asked them if you could, put something on NSC's campus that you think would help you out, what would it be? Of course, the first thing is always food, but one of the things that also comes up is a gym. So let's assume that we at NSC are going to build a gym and we would like to know whether we should have more cardio machines or more weight machines and free weights in the gym, because we want to make sure that students have a good experience and they're not, waiting in line for what it is that they need, and et cetera, et cetera. So you decide to survey 40 NSC students and you ask them two basic questions. When you're at the gym, how often do you work out on cardio machines? So your participants can answer from 1, which means never, all the way to 5, which means often. Then you ask them a second question. How often do you work out using weights? Again, they can answer from never all the way to often. So you're going to go ahead and look at these data and figure out if people like to use cardio machines more or if they like using weights more. So let's look at our data. So I'm going to show you a graph of the data because I want you to get used to graphs. So what we're going to see is a sort of maroonish bar for how much your participants like cardio, and then a more yellowish, brownish bar for how much people like to use weights. Here we have the scale that we asked them on. 1 meant never, and 5 meant all the time that they use this type of exercise, machine or weights. So we'll just call it that preference. So let's say that what you found is that participants on average liked or used the cardio machines about, even. So 3, almost a 3 out of a 1 to 5 scale, and very similar for weights, just above a 3 on a 1 to 5 scale. So let's say that you run a t-test on this. This is a related samples t-test, and you find that it is not, in fact, significant. There is no difference on whether your participants used cardio machines or weights. Okay, so that's easy enough. Now, I imagine that some of you are probably thinking, well, I don't know if that would be the same if we looked at different types of NSC students. Perhaps if any of you have spent any time in a gym, you would say something like, you should probably look at it by gender, right? So why don't we go back to our original survey, and let's say that included with these two questions, you also ask them, what is your sex? And they responded by checking either female or male. Okay, so now we've added this other nominal variable. So now we can actually analyze the data looking at how females respond versus how males respond. So let's see what that looks like. Again, I'm going to show you a graph. This time I'm going to separate the females on the left and I'm going to put the males on the right. Both will still have a cardio bar, so that's going to tell us how often it is that they use cardio machines, and both will also have a weights bar, so how often it is that they use weight machines or free weights. Again, we have the scale on the left, 1 from never to 5 often. Okay, so again, we're going to have 2 sets of bars for females and then 2 sets of bars for males. Okay, so what do we find for females? They overwhelmingly prefer cardio machines. Okay, so they don't necessarily hate weights, but they do definitely like cardio machines better. And if we look at males, they are preferring weights. Okay, so we see that here the difference is that women prefer cardio machines, but here we see that men prefer weight machines and free weights. Okay, so we have a difference depending on the gender or the sex. Okay, so let's take a look at these differences. So let's see how cardio changes depending on gender. So I'm just going to put a little line here to represent. This is the difference, right? The difference in how much participants prefer cardio depending on whether they're men or women, right? And we'll do the same thing for weights. So here we see the difference between men and women here. So we see that the effect, this line sort of goes down for cardio, but it goes up for weights, right? So you'll see that these lines cross, all right? And this crossing is going to be important as you go on to interpret graphs, all right? So we're going to be using this little trick of drawing lines to see if they cross, because that crossing or not crossing is going to become important. So I just want you to make a mental note of that. We will come back to it when we go to interpret graphs. So what you would say if you were the person conducting the study is how much students use cardio machines and weights depends on whether they are female or male. And you can imagine that this kind of finding is probably pretty common in behavioral research. So whether someone is affected by a treatment probably depends on something about them. So whether it's their gender, it could be their age group, it could be whether they're rural or urban dwellers, it could be if they are married versus not married. So these kinds of things become important. In addition, we can start to look at more than one treatment at a time. Okay, so we don't just have to confine ourselves to one treatment. We can do more than one. So instead of having females or males, we can have something like whether they are on a diet or not, or something like that, right? So we can start to mix and match different treatments within one study. This is what makes this design very cool, that we can do a lot with one study. So let's take a look at what a study might look like using this kind of idea. And so with this example, we're going to go into what we call main effects and interactions. Okay, so these are the meat of running a two-factor ANOVA, your main effects and your interactions. So let's say that Dr. Sanchez wants to know if putting a small alarm on the tops of medications will help patients miss fewer days of their medications. She gives half a 50 patients small alarms that they can set and attach to the bottle tops. The other half do not get an alarm. Okay, so now we already know that these small alarms are a treatment, right? Some participants will get them and some participants will not. But she's also curious if the alarm's effects will be different by patient type. Okay, so she decides to group participants by those who are continuing a medication they have been on for 6 months or more. We'll call this the continuing group. And then those who are starting a new medication for the first time. So we'll call this the new group. So now we have two different factors going into this study. One is whether or not they get the treatment of an alarm. So some will get the alarm and the others will not get the alarm. But we also have this other IV, right, which is whether patients are continuing something they've already been on for a long time or if they're starting a medication that they've never taken before. And so this might play a role in whether the alarm works. So that's what she's going to look at. So just to make this very clear to you, let's make a table showing the 4 different groups that we have going on in this study. So we know that half of our participants have an alarm for their medication and half of our participants do not. Okay, so because this is 50 patients, we would assume 25 and 25 for each. The other thing that's happening is that we have some patients continuing a medication and some who are not. So what we're going to do is what we call crossing these two variables. Okay, so one is going up and down, the other is going left to right, so we're going to cross them. What that gives us is 4 distinct separate groups. Okay, so the first group has a medication that they are continuing and they are now adding a small alarm to the top of the bottle. Okay, we then have another group that is also continuing their medication, but they do not get a small alarm. So we're going to be able to compare getting the alarm versus not getting the alarm between those groups. In addition, we have some people who are starting a new medication who've never taken it before, and they also get a new alarm. So they're getting 2 new things. They're getting a new medication as well as an alarm. And the last group has a new medication, but they do not have an alarm. Okay, so we have these 4 distinct groups. Now, when you go to analyze these data, you're actually looking for 3 different effects. Okay, 3 different effects. 2 of them are called main effects, and 1 of them is called the interaction. So, the first main effect we can look at is simply the alarm groups, right? So whether they're continuing a medication or getting a new one, versus the no alarm groups. So we can see if these 2 groups do better than these 2 groups. For the moment, ignoring whether they're continuing a medication or starting a new one. So this is very similar to an independent samples t-test, right? We're just going to look to see if having an alarm helps participants miss fewer days than not having an alarm. So that's one main effect. The second main effect I'm hoping you've maybe already picked up on is that we're going to go the other way. So now we're going to look at whether continuing a medication results in fewer missed days or starting a new medication results in fewer missed days. So we can look at both of these, what we call main effects, separately. Okay, so we can first look at the effect of the alarm, and then we can look at the effect of continuing a medication versus a new medication. The interaction is the third effect, and this is asking whether having an alarm causes a difference in missed days, but depending on whether they are continuing a drug or starting a new drug. So I'm going to say that one more time. The question you're asking is, does the effect of the alarm depend on whether the patient is continuing a medication or starting a new medication? Okay, so we could get the effects, we could find that the effect of the alarm is one way for the people continuing their medications, but a very different way for people who are starting a new medication. So this particular design for research helps us answer all three of these questions all at once. I think it's cool, amazing. All right, so we can look again, two main effects and an interaction. The main effect here is alarm versus no alarm. The second main effect is continuing versus new medication. And the interaction is looking at whether the effect of the alarm depends on whether they're continuing a medication or starting a new one. So let's look at some data if Dr. Sanchez had gone ahead and collected some. So I'll again show you in a graph form. Okay, so we're going to put the bars for continuing here, right? The bars for the new medication here. Both groups of patients will have a bar for those who got the alarm and a bar for those who did not get an alarm. You'll notice that my scale starts at 0 and goes all the way up to 7. We're looking at days missed for 1 month. So if they miss 7 days, that's a whole week. That's a lot. We want patients to be missing fewer and fewer days, right? So we want them as close to 0 as possible. So again, we're going to have 4 bars, 2 for continuing, 2 for new. So let's see what happened. So for our patients who are continuing a medication that they were already taking for at least 6 months, we see that the patients missed more days, right? More days here when they did not have an alarm than when they did have an alarm. Okay, so this looks like having the alarm helped the patients miss fewer days. Oh, that's good. That's really good news. All right, so let's see what happened with patients who were starting a new medication they had never been on before. Whoa, in this case, it looks like we got a similar effect. Patients who were given an alarm missed fewer days than patients who were not given an alarm, but that difference is whopping, right? We go from less than 1 day all the way up to 6 days. This difference is a lot bigger than this difference, okay? So it looks like even though the effects are similar, they're slightly different depending on the type of patient we're looking at. So let's go ahead and figure out our main effects and our interaction. So for the first main effect of alarm versus no alarm, we simply want to see are the red bars, I'm just going to call them red and brown to make it easy, are the red bars on average for both groups higher or lower than the other bars? Okay, so in this case, we see that both of the red bars in both of these groups are lower than the brown bars. Okay, so that means that we have a main effect of alarm. Okay, so it looks like patients with an alarm always do better. So that's good. We know that the alarm works. The other main effect is looking at just continuing versus new. So I want you to simply imagine if I found the average of these 2 bars and I found the average of these 2 bars, would those bars be different? Okay, in this case, it doesn't really look like it, okay, but usually I'll be giving you some numbers so that you can tell. So it looks like we have a main effect of alarm. We don't really have a main effect of group, so type of medication, whether they're continuing or starting a new one. Now what we need to figure out is there an interaction? Okay, so does the effect of the alarm depend on whether they're continuing a drug or starting a new drug? So I'm going to use the little line test, okay? So let's look at the difference between no alarms. So that's the line. So it looks like It increases for patients who are starting a new drug. So that kind of makes sense, right? You're starting a new drug, you forget to take it because you're not used to it. So you might miss more days. Now, let's look at the effect with an alarm. Oh, that one goes down, right? So we see that patients miss when both groups have an alarm, the patients who are starting a new drug tend to do better. Okay, so what we see is that these lines are doing different things. In this case, the line is going up. In this case, the line is going down. That's good. That means we have an interaction. The other way that you can think about these lines is if you were to extend them. So if you made this line keep going and you made this line keep going, at some point they would cross. Okay? And so if your lines look like they cross at some point, even if you're extending them in your mind, if they cross, that's an interaction. If they do not cross, then it is not an interaction. If they don't cross, the lines are basically doing the same thing. They're moving in the same way and they're parallel. So again, what these lines are representing is the movement, right? So we see that it's going up when we're looking at the no alarm condition, but it's going down when we're looking at the alarm condition, right? So that means that the effect changes depending on the group that we're talking about. Whew. All right. So let's keep practicing so we can get used to this. I know that this is a little bit tough to wrap your head around, but again, like I said, this test is awesome because it lets you look at so many different things all in one test. But that's also sort of the downside. You got to look at all the things whenever you run the test. Okay, so those of you who have been watching my lectures probably have gotten very tired of this question, but I like it, so we're going to use it again. Do men over the age of 35 years get better sleep if they exercise or meditate regularly? So in past lectures, I have talked about exercising and whether that may affect sleep quality. In this case, we're going to look at both exercise and meditation at the same time. So in a couple of slides ago, I mentioned that not only can we look at how a treatment affects different groups, we can also look at more than one treatment at a time. You guys, this is amazing. Oh my gosh, it's so great. Okay. So let's look at this question. So really what we can start to do with this question and this setup is ask, would meditation and exercise together help even more than just meditation or just exercise when it comes to sleep quality? So like I said before, what we're doing is we're taking two independent variables. One is meditation and one is exercise, and we're crossing them. Okay, we're crossing them. We're going to create 4 different groups. So let's look at our 2 independent variables. In this case, we're going to call them factors. Okay, so factor 1 is exercise. So as you probably remember from the last examples, we're going to have one group that definitely exercises, right? We will define this as, let's say, 3 times a week. So that's how we'll define exercise. Level 2, you should know, does not exercise. So for factor 1, exercise, we're going to have 2 levels. Okay, so remember, factor is the independent variable. Level is the specific amount of treatment that the person is getting in that group. Our second factor, hopefully you can guess it, is meditation. Okay, so again, we're going to have 2 levels of meditation. One is participants meditate. So let's say that we ask them to meditate every morning for 5 minutes. Okay, so on top of exercising 3 times a week, they're also going to meditate 5 minutes a day. The other group does not meditate at all. Okay, so just like we did with type of medication and alarm or no alarm, we're going to cross these 2. So this is what it's going to look like. We have one factor on the left with 2 levels, exercise, no exercise. One factor on the top, 2 levels, meditation, no meditation. All right, we just went through that in the last slide. So that means we'll have 4 distinct, separate groups. The first group will combine exercise and meditation. So exercising 3 times a week, meditating 5 minutes every morning. The next group will be simply exercise because we're using the level 1 of exercise and the level 2 of meditation. Okay, so remember, we're just combining. So this box means exercise and this box means no meditation. So hopefully you can now figure out what would go in this box. I'll give you a second. Hopefully you said just meditation, right? So in this case, we're going with level 2 of exercise, which means no exercise, and level 1 of meditation, which means they are meditating. So in this particular group, they're only meditating 5 minutes a day. Okay, hopefully not 5 times a day. That's a lot. So 5 minutes a day. And then the last box, this last group, is level 2 of both. No exercise, no meditation. So they don't do anything. They play video games or whatever. I don't know, whatever they do. Okay, so we now have 4 distinct groups. I want to make that very, very clear. So you are either in this group, in this group, in this group, or in this group. That's it. I think I've said this before. Often you don't even know that the other groups exist until you're done with the study, right? So you may have been told meditate 5 minutes a day and tell us how your sleep is. And at the end of the study, they're like, oh, by the way, we also had some other people who were exercising and meditating. And you're like, what? I didn't know that. Okay, so these are 4 separate groups of people. All right, so how would we do this hypothesis testing? So because there are lots of hypotheses here, I'm only going to state the null hypotheses for now. And then, because you're rejecting it or failing to reject, but I want to make sure that you understand why there are 3 null hypotheses. So basically you have a null hypothesis for each main effect and then for your interaction. So your first null hypothesis is that factor A has no effect. So usually when we're doing this 2-factor ANOVA, we label one as factor A and the other as factor B. So in this case, factor A will be exercise. Okay, so this means that there's no difference between exercise and no exercise. So I want you to hopefully realize that this looks a lot like an independent samples t-test. Okay, so it's just looking at these 2 levels of the one factor. So we're going to ignore the other factor for this particular hypothesis. Okay, so no difference between exercise and no exercise in terms of sleep quality. The second null hypothesis is that factor B has no effect. So in this case, that's meditation. So we'll say there's no difference between, that should say meditation, between meditation and no meditation. Okay, so again, just like an independent samples t-test, we're just going to look at meditation versus none alone. We're going to ignore the other factor for that hypothesis. And then the third hypothesis is including both factors. So there's no interaction between factor A and factor B. So the effect of exercise does not depend on whether participants are meditating or not. So you'll notice that this null hypothesis is always the one that we hope is not true. When you run a 2-factor ANOVA, it's because you strongly believe that there is an effect that changes depending on another factor. So in this case, I would be very surprised if meditation and exercise together did not improve sleep quality above and beyond just meditating or just exercising. All right, so we run these 2-factor ANOVAs mostly because we're interested in the interaction. having main effects is nice, but it's not usually the main focus of running a two-factor ANOVA. It's really about looking at this interaction. Okay, so once you have set up your null hypotheses, you're going to collect data for 4 separate conditions. You as a researcher, clearly you as a student in this class will not be collecting any data. Once you do that, you compute F ratios and you compare to your F distribution, which you've done for the one-way ANOVA. Okay, so that means that each effect will have its own F ratio. So we're going to have 3 F ratios. One for the main effect of factor A, the second for the main effect of factor B, and the last one for the interaction between the two. So like I said, main effects are nice, but often it's the interaction that we're truly, truly interested in. Okay, so hopefully that F ratio will be significant. And then finally, you decide whether to reject all 3 of your null hypotheses. So, like I mentioned in the beginning of this lecture, we will not be computing the F ratios for the two-factor ANOVA. I'm more interested in your ability to understand the null hypotheses here and to interpret the graphs of the data and to know what that would mean in terms of a study or real people. So let me go over really quickly how the two-factor ANOVA is figuring out whether your main effects and your interactions or interaction is significant. So as you remember from learning about the ANOVA, we are now analyzing variance. So when we were looking at z-scores and when we were looking at t-statistics, we were really interested in mean differences. Now that we're looking at the ANOVA, we're really interested in where is the variance coming from. Okay, so remember, ANOVA stands for analysis of variance. So we're really interested in all of the differences in the scores that we have obtained. And we're going to use the ANOVA to basically figure out what is contributing to that variance. And then we can see if our factors are contributing a significant amount of the variance. So what you're doing is you're splitting all of the variance, all of it, into what is contributing to that variance. So as you think about your main effects, these are the mean differences between levels of factor A. Okay, so it's similar to the t-test, but instead of looking at, we're still analyzing variance, right? And then we're also looking at the same time mean differences between levels of factor B. Okay, so we're looking at variance and looking at those mean differences. In the interaction, we're looking at any mean differences that are not accounted for by the main effects. Okay, so there might still be some variance left over that we cannot account for in the other ways. So this interaction would mean that the effect of B depends on A or vice versa. So in our case, we might end up saying something like, meditation only helps sleep quality if participants also exercise. So we can imagine that meditation alone may not help sleep quality, but it really helps sleep quality if the participant is also exercising. All right, so we're again looking at the variance. Where is it coming from? We're going to look at 2 main effects plus an interaction. Oh, sorry, the other one, the vice versa, I forgot I added this, is that exercise only helps sleep quality if they do not meditate. So maybe it's that exercise and meditation is a whammy, but exercising alone is good. All right, so we have now a few different possibilities for how these things may interact. But I want you to be able to look at data and tell me if you can actually see an interaction happening. So let's look at this in a little bit of a flow chart. So we have the total variance, right? So ANOVA, we're analyzing the variance. What we've already learned is that the variance can come from within treatments variance. So basically, this is just the variability you naturally have within your groups, right? Not everyone is exactly the same. And so we're going to sort of take that out. We're going to count it out. And then we also have this between treatments variance, which you learned about in the one-way ANOVA. So this means that there is variance above and beyond just natural discrepancies between people that is being caused by the treatments that we have introduced into the groups. All right, and that's what we're interested in, is that above and beyond what we would find naturally within the groups. And then with the two-factor ANOVA, we're taking another step, right? We're going to see how much of that between treatments variance, because remember, now we have 4 different groups, how much of that variance comes from factor A, factor B, and the interaction. All right, so we're trying to account for as much variance as we can within this one test, you guys. One test. Okay. All right, so let's look at, again, our setup for this. So our factor A is going to be exercise, right? So we're looking at exercise versus no exercise. And factor B is going to be meditation. So we can look at meditation versus no meditation. So let's run a quick hypothesis test for this example. So we state our hypotheses. I'm only going to write the null because it takes up a lot of space. And really the null is the one that we want to reject or fail to reject, right? So let's take a look. So first we're going to say something about factor A. There is no difference in sleep quality between men who exercise and those that do not exercise. So this is the main effect of exercise. Okay, so that was factor A. So the next hypothesis is going to be about the effect of factor B. So I'm hoping that you can think ahead a little bit to what it might be. There is no difference in sleep quality between men who meditate and those that do not meditate. Okay, so again, we're looking at a second main effect, the main effect of factor B, our null, of course, being that there's no difference between men who meditate and those who do not. And finally, we have our null hypothesis for the interaction. The effects of exercise on sleep quality does not depend on the level of meditation. So remember, this is the null, and this is the most important null hypothesis, the one that we really want to reject. Okay, because if we've gone through the trouble of creating a huge study that combines these 2 factors and, making sure that they're going through 2 levels, it's a lot of work. So you really are looking forward to seeing if this interaction is significant. Now, we usually set our criteria with our F values, our critical F values. In this case, because you're not going to calculate the F ratios on your own, I'm just going to say let's set the criteria using an alpha. Usually alpha of 0.05, unless, of course, you are told otherwise. Usually you might see an alpha of 0.01 if you are told otherwise. Okay, then you're going to look to the graph and F ratios. So you'll either get some output from some sort of software that helps you run these, or you will look to the graph to see if it looks like there are main effects or interactions happening. From there, we're going to decide whether to reject the null hypotheses or fail to reject the null hypotheses. All right, so we're going to look at some possible outcomes for this particular study so you can get used to looking for main effects and interactions. All right, so let's take a look at what these data might look like when they're graphed. So these graphs should start to look familiar to you. So I'm going to graph exercise on the left. So the sleep quality that these men are getting on the left if they exercise, and on the right if they do not exercise. Okay, and both groups, both exercisers and non-exercisers, will have a bar for meditation and a bar for no meditation, because remember, we cross these. So if we look at the group who exercises, we see that they're doing better in terms of sleep when they meditate. Okay, so meditation plus exercise works better than just exercise. Okay, now if we look at no exercise, we see a very similar process. So participants are sleeping better when they're meditating than when they're not meditating, right? And even if they're not exercising at all, we do get sort of a less sleep quality overall, right, if they're not exercising. So let's just look at the data real quick. So I'm going to show you a table of the data, so basically the numbers, so that you can see how these bars came to be. All right, so here we see that meditation plus exercise is kicking butt, right? This is a 1 to 7 scale. So 6.41, they're sleeping really, really well. If you meditate or exercise, you're doing all right, pretty good. And if you don't exercise and don't meditate, then you're not doing very well, okay? So you can also see that these numbers are bigger than these numbers. So that tells us that there's a main effect of meditation. And we can also see it here. Those lines came up a little early, but we can also see it here, right? And the two red bars are both higher than the two brown bars. So that means that we have a main effect of meditation. It looks like meditation helps sleep quality, even if we ignore exercise. Now, what we also see is that these two numbers are bigger than these two numbers. So now we're looking at the main effect of exercise. So people who are exercising tend to be sleeping better than people who don't exercise. And you can also see that here, right? The middle of these two is about here, and that's definitely higher than the middle of these two. So we see a main effect of exercise. So remember, we have two main effects and an interaction. So we're more than likely going to reject the null that there is no main effect for factor A, which was exercise, and we're more than likely going to reject the null that there's no main effect of factor B, which is meditation. Okay, now the last thing we need to look at is interaction, and that's what those lines were for that came up a little early. So remember, we have to see, does the effect of exercise depend on the level of meditation? So we're going to use that little trick of doing the lines. Okay, so here we see the effect of meditation, it's going down. Sorry, or no exercise, it's going down. And then we also see that the same effect happens in the no meditation group. Okay, so these lines look very similar. They look almost parallel. I'll take that. So it looks like these particular lines would not cross, and we would not have a significant interaction. So in this case, it looks like we have two main effects and no interaction. All right, so it looks like exercise is good, meditation is good, exercise and meditation, it's fine. Right. Okay, so let's see another potential outcome for this study. So we're going to keep the same study, but the data are going to look slightly different. All right, so let's look at some new data if I'd run this study. Again, we're going to put the exercisers on the left and the non-exercisers on the right, and our red bars are going to be the meditation people and the brown bars are going to be the no meditation people. So in this case, we see a slightly different pattern. We see that participants who are in the exercise condition are getting better sleep if they don't meditate. So exercise alone is working better than exercise plus meditation. If we look at the non-exercise group, we're actually getting the opposite effect. Participants are sleeping better if they are meditating than if they are not meditating. So let's take a look at these data. So here, let's look at the effect of factor A, which is exercise. So do these numbers look bigger than these numbers? And when I say these numbers, I want you to think of the average of these two numbers, right? So do these numbers on average look bigger than these numbers here? So not really, right? It doesn't look like exercise is by itself doing a whole lot, and we can also see that here. The middle of this is about here. The middle of this is about here. So it doesn't look like exercise is doing a lot better than not exercise. Now let's look at the main effect of factor B. Does it look like people who are meditating are doing a lot better than people who are not meditating? So again, we're going to compare these numbers on average to these numbers on average. Again, not really, right? And that makes sense because meditation is lower here but higher here, right? And so it doesn't look like there's a main effect of meditation. Now let's look at the interaction. So we're going to see if the lines, cross. So let's make a line of the change in sleep quality for exercise versus no exercise in the meditation group versus the no meditation group. So we can see that this effect here is going up and this effect here is going down. So in this case, we do have an interaction. In fact, they cross right in front of us, right? Which means that the effect of exercise depends on whether people are meditating or not. In other words, exercise seems to work well when participants are not meditating, and the vice versa is true as well. So people tend to sleep better when they're exercising but not meditating, and when they're meditating but not exercising. So it looks like in this case, the doing both or doing neither actually hurts your sleep, okay, more than just doing one. And you can see that perhaps this group is taking up too much time doing other things, so maybe they feel stressed out or something and they can't sleep, right? So this is a really cool interaction, and again, it's fine. The main effects aren't significant. That often happens when you have an interaction, so it's fine. I'm quickly going to show you some SPSS output so that you can just see what this would look like in data analysis and if you were to run this on your own. So this is a really blown up version of SPSS output. Even if you are not working with SPSS output, I think this table is really interesting because it shows you all of the things that we normally work with when we are computing our own F ratios. So if you are looking at SPSS outputs, you'll notice that right now these are sort of fill-in variable names. So variable 1 is whatever our dependent variable is. In our case, that variable would have been sleep quality. And then variable 2 and 3 are the independent variables. So that's exercise and meditation. And then this little asterisk here between these two, that's the interaction term. Okay, so we're basically looking to see, is this significant? Is this significant? Those are our two main effects. And then this one is whether our interaction is significant. Now this table has a lot going on, but I want you to know that if you do run this on SPSS or another software that gives you this kind of output, these first two lines are unimportant to you. Literally ignore them, okay? So when you're looking for significance, these two lines are unimportant. All you're really interested in is these three here, okay? And of course, you'll name them, so you'll be able to see what they are. So you'll notice that we have, those things that we calculate when we calculate F ratios. We have our sum of squares, we have our mean square, right? You learned how to do that. Our final F ratios here, and then the significance. This is the same as your p-value, okay? So your p-value, don't forget, is simply the probability that you got this F ratio just by error, right? And we want that to be as low as possible. We had set our criteria at alpha equals 0.05, so we want that number less than 0.05. So really what you're looking at is in this box. So when we look at the effect of variable 0002, which we would say is exercise, we have an F ratio of 3.75, but its significance is only 0.071. So it's close, but not close enough. So in that case, we would fail to reject the null hypothesis that exercise had an effect on sleep quality. We see the exact same thing for variable 0003, which would be meditation. We have this F ratio. We have again a significance or a p-value of 0.071. Again, not below our alpha of 0.05. And so we cannot reject that null. We fail to reject the null. However, our interaction term, that's a whopping F ratio, is definitely below a 0.05. So we can safely reject the null hypothesis that the effect of exercise does not depend on the level of meditation. So in this case, it looks like whether exercise helps you depends on whether or not you're also meditating, and the vice versa. Whether meditation helps you depends on the level of exercise that you have. All right, so I know that ANOVAs with 2 factors are a little crazy. I think that the idea, so the reason I set it up with this gym at NSC idea is because I think the idea of comparing 2 different factors is intuitive, because you're looking at are these 2 groups affected differently by a treatment, or do these 2 treatments interact in some way to produce a different effect than either one alone? I think that is intuitive. I think it's when you have to go and interpret the data and look at whether you have an interaction. I think that becomes the sort of harder part, but I think that with enough practice you can definitely do it. So on the next lecture I will be going through practice. Of course, we will not be actually calculating the F ratios, so instead what I'm going to do is have you set up studies using 2 factors and then look at some data and interpret the main effects and interactions. All right, so I hope everyone thought a little bit that this was cool, because I think it's cool, and that you get your practice on the next lecture. All right, thanks everybody.